So the title of Eric's talk tonight is Agricultural Climate Change Mitigation. And just want to tell you a little bit about Eric, although I could go on for hours about him. Eric Toensmeier is the director of the Perennial Agriculture Institute. He's a senior fellow with Global Evergreening Alliance. He's a former senior fellow with Project Drawdown, which is a book that everybody in the climate movement should have as their text to draw on. And he's also author, among many other books, of The Carbon Farming Solution. And I just wanted to say that it is such a gift for all of us in Western Massachusetts that we have Eric Toensmeier living right here in Holyoke, Massachusetts. He's an extraordinary resource. He's known globally. He helps people all over the world. And he's been a real incredible support for us in Climate Action Now from the very beginning of our efforts to do this kind of work. And he really is an inspiration. And I want to say that Eric lives what he teaches. And I was hoping that Eric maybe would share a little bit about the urban paradise that he's created, that you've created, Eric, on a tiny lot in your backyard in Holyoke. It's a wonder to behold. I've seen it in person. And so I think he's going to share a little bit about that. But tonight, the focus of Eric's talk is it's going to be an overview of agriculture as a source of emissions, but also having the potential to reduce emissions and sequester carbon. And that whole idea is that it's part of some people call a balanced breakfast of climate change mitigation that includes transformation of transport. How does food get to where it goes, et cetera? Industry, electricity, and other sectors. And after his presentation, we will be so fortunate that he is going to be here for questions and answers. So, and feel free if you have a question to, put it in at any point in the chat. And now for our speaker, I want to warmly welcome and introduce Eric Toensmeier.
Great. Well, thanks very much for those kind words, and it's always a pleasure to be here with you folks. This is my second or maybe third event we've done together, so it's great to be here. And part of the way I see my role is to provide, the sort of the latest scientific information to the people who are actually doing the movement work, which is what is essential and necessary, and maybe to provide a little bit of hope as well. I have found that the more I look, the closer I look, the more hopeful I get in terms of the potential of the mitigation solutions. The hard part is getting people to do them, which is where all of you come in. So what I'm going to talk about tonight, a lot of it is coming from a new publication that I've been writing for Project Drawdown, which will be out any day. It might be a month, I don't know, but it's in like the final layout. And the title that we decide on is Farming Our Way Out of the Climate Crisis. So it'll be up on their website, by the end of the year anyway. And we try and give just a big overview of what are the sources of emissions from agriculture, what's the potential to reduce emissions in agriculture, what's the potential to sequester carbon in agriculture, and in particular looking at some of the confusions and myths and stuff that come up around carbon sequestration in particular. Seems to attract a lot of it's a complicated subject. So we'll go into a little bit of that tonight, and I'll just give us a kind of a breezy walk through that world. So we're looking at the whole big picture, right? So very at the global scale, agricultural production is responsible for about 12% of humanity's emissions. Land use change, which is basically cutting down forests, most of which is for agriculture, is another 9%. And the rest of the food system gives us another 7%. That would be things like the energy that it takes to run refrigerators, and transportation and food processing and food waste and sort of everything else after it leaves the farm on its way to you and then ends up in a landfill or a sewage treatment plant or something. That's kind of what that other food system piece is. So it's a big piece. Um, Actually, it is just about the same amount of emissions as electricity generation. So it's big. It's really big. Um, and That's the first thing to say. And within individual greenhouse gases, it's different. Within carbon dioxide, about 5% of it. Oh, I don't have percentages on these. I'm sorry, that's gigatons. Anyway, you can see on the left there, you know, some of it's from in terms of carbon dioxide, that's really coming from the land use change from deforestation. In terms of methane in the middle, an awful lot of of anthropogenic or human caused methane is coming from agriculture. And on the right, 88% of nitrous oxide is coming from agriculture. So we are agriculture is particularly responsible for these extra powerful gases like nitrous oxide and methane. It's not so much a source of carbon dioxide. It's a big one, but not huge, not dominant in the way it is with those other gases. And all those figures will be in this publication, which will be out one of these days. And the way that John Foley, who's the director of Drawdown these days, likes to think about this is he says, well, if we think about about climate change as a problem of we left the water on in the sink in the bathroom, and the water's running and it's flowing over the sink and it's coming down onto the floor of the bathroom, the first thing to do is turn off the sink. And that is reducing emissions from agriculture. And the second thing to do is mop up the floor, and that's carbon sequestration. So sequestering carbon alone, mopping up the water without turning off the faucet doesn't do you very much good, but turning off the faucet and leaving the floor totally wet is going to rot out the floor of your bathroom. So both are necessary. But they're different. They do different things. And actually, we can look at emissions reduction has benefits of it happens right away, whereas carbon sequestration can be a longer process to kick in. There is a limit in terms of biosequestration, a certain number of decades you can sequester carbon for, and then you basically get filled up in the soil and in the above ground biomass, whereas you can keep reducing emissions every year forever. Emissions reduction is permanent, but carbon that we sequester in soils and in biomass can be lost by a return to bad farming practices or by climate disasters like fires, as we saw this year so powerfully in so many places. And it's easier to measure emissions reduction than soil carbon sequestration, although above ground carbon sequestration is easier to measure. And all of them have very powerful impacts in terms of how many gigatons of carbon dioxide per year they might be sequestering or reducing. So we really need all of them together. And the global potential, this is really interesting, is that the projected emissions for 2050 are between 8 and 9 gigatons of carbon dioxide equivalent for agriculture as a whole. And what you can see here, the low impact shows the combined potential of the low estimates, and the high impact shows the combined potential of the high estimates for emissions reduction, soil carbon, and biomass carbon. At the high end, we may actually be able to sequester more carbon than we are emitting in agriculture, which is really great news. But again, that may only be able to happen for a certain number of decades. It's not a permanent situation, but it's a very welcome one for sure. So let's look a little bit about how to reduce emissions. So food waste is the first thing, and especially in terms of reducing the emissions from land use change, from deforestation, the first thing we can do is use less stuff. That so much of what's driving deforestation is increases in the amount of beef that's eaten globally and increases in the amount of biofuel that is being used globally. So if we can contract that growth or reverse that growth, that's a big deal. So food waste, we're wasting 30 to 40% of the world's food at this point. And that's a pretty embarrassing state of affairs. So imagine if we just stopped wasting food, we could cut all those emissions from food production by 30 to 40% as well. Um, and the saying on here is that if it was a country, it'd be the third largest emitter. It's not quite accurate because the figures for China and the US do include their food waste. But just basically to say, wow, it's a really big deal. It's a really big problem. Not only the emissions that it takes to grow that food, but also when it ends up in a landfill, it turns into methane, which is bad as well. So food waste is really big, and it's the first place to start, and everybody agrees that it's terrible. Nobody likes food waste. And the second one is diet change, and we'll look at livestock in a minute, but just to say that not all foods are created equal in terms of their emissions, some much more than others. What I really like about this particular article is it breaks down like how much of the emissions from beef are from deforestation versus from emissions on the farm versus from transportation and so on. So you can see now these still are global averages and there's going to be differences and stuff, right? But I was horrified to see chocolate and coffee so high on the list. That is very, very, very sad to see. And that's because there's a lot of, especially for chocolate, there's a lot of land use change in East Africa. There's a lot of deforestation in places like Ghana for chocolate production. Not all chocolate is that way. Not all beef is done in this way and so on. But globally, there are foods that are much more emissions intense. And we want to change the way those are produced, but also reduce our consumption of those things. This was really sad. It's a little bit of a heartbreaker. So let's just walk through livestock for a minute. Most of the world's farmland is used to produce livestock. A third of the crops we grow are used to make food for livestock, feed for livestock, and yet they only produce about 10% of the calories that we consume while producing 80% of emissions. So it's not a very good scorecard for livestock at the global scale when you look at it like that. And one of the reasons is that often we feed things that people can eat to livestock, and then most of that food is wasted. So you can see, like for pork production, only 9% of what we feed to them, if we feed them 100 pounds of grain, we get 9 pounds of pork that we can eat. Which is just not a very efficient way to produce food. With that said, there are lots of things livestock can eat that we cannot eat, and that is a very different kind of a question. But broadly speaking, it's not a terribly efficient way to produce food. But they do have their advantages. So a lot of the world's farmland is grassland that's more or less dry enough that it's not a good place to produce plants that people can consume directly. We can also raise livestock in places where it's really hard to grow crops, places that it's really steep or really rocky or really remote or something like that. And they can eat things that we can't. They can eat crop residues like corn stalks and they can eat food waste, and they can eat grass, which we can't eat, and they can eat the leaves of trees, which is great. And they can play a role in cycling nutrients to improve soil fertility. So it's not that there isn't a potential role, but the way we've been raising them is really pretty atrocious in terms of global land use. There are some climate friendly livestock systems. We'll talk about some in a little while. But here's the thing: if we raise livestock only on the things that we can't eat, only on the grass and the crop residues and the food waste, there's an awful lot less livestock around. The amount of livestock protein that would be part of the average diet would be much, much less than Americans consume today. Much, 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 much less than Americans consume today. So it's not that there can't be some. It's that it should just be a lot less and raised in the best possible way is basically my personal sense of that. And there are people who will tell you that, we should all be eating 3 grass-fed steaks a day and all that. And I just don't see the land being available for that to raise livestock on pasture, even doing it really well. takes about twice as much land as it does to grow the corn and soybeans that would feed them if they were in a feedlot. Now, we don't like feedlots. We'd like to do away with feedlots, but to grow the amount of livestock that we're producing in feedlots now in a pasture system would require huge amounts of deforestation. So there's, it's not entirely neither. There's absolutely no doubt in my mind that a vegan diet is excellent in terms of climate, unimpeachable. But there is also a potential role for livestock. And I think the feasibility of everyone in the world becoming vegan in the next decade is probably fairly low. Anyway, I do vegan days now, each week I try and do a few vegan days. But there is a potential role for some, and we'll look at a few of those in a little while. So, okay, reducing emissions from agriculture. What are the sources of emissions in agriculture? Well, the biggest one is enteric fermentation. That's the digestion of ruminant livestock like cows and sheep and goats and so on. That's the biggest source of emissions from agriculture, and about 2 gigatons a year, which is a very large amount of emissions. The next largest is manure, which also comes from livestock. And that's a couple different kinds of manure. There's manure that's left on pastures. In that case, it's mostly the urine, actually, that's a problem. It turns into nitrous oxide. There's manure that's applied to crop fields if you do it at the wrong time. That can be a problem. And then there's the piles of manure outside of barns and feedlots and stuff. That is a problem. Synthetic fertilizers is the next one. The issue there is that when you over apply synthetic fertilizer, it off gases as nitrous oxide, which is 298 times worse than carbon dioxide. And also, we use a huge amount of fossil fuels to manufacture synthetic fertilizers. It's a very energy intensive product. Then there's a bunch of methane coming from rice production, and then there's a few other kinds of emissions. So this is sort of the breakdown, and you can see that most of that is coming from livestock. That's just something we have to square ourselves with. So how do we reduce enteric fermentation? How do we make ruminants make less methane? The first would be to have less of them. That's a very effective technique. They can eat, if we can improve the digestibility of their feed, that makes them basically, the less time it spends in their gut, the less time it has to make methane. There are certain feed additives like this beautiful seaweed you can see there, Asparagopsis, and a number of other things that you can feed added 1 to 2% of their diet. And those things reduce methane. And they can, it looks like some of them you can stack up, like if you do this kind, like nitrates plus flaxseed oil plus something else, each of them may be able to have a 10 to 20% impact, and you may be able to get a cumulative impact. But we don't yet know how long does that last? How reliable is that going to be? Other health impacts for the animals and so on. So that's still an early area, but a lot of people are working on that. We can take better care of them so that they're healthier. We can improve the quality of forage with grazing. So if you are grazing in such a way that there's always nice tender growth for them, tender grass makes less methane than tough old grass. Tannins and from some tree leaves and some other kinds of forages that they can consume also reduce methane production. So there's a whole range of things that can be done. None of them comes close to 100% as far as I'm concerned, but it's nice to know that there's something out there. Then from manure emissions, in terms of manure on pastures for what works around here, the best thing is just to restore degraded pastures. We found that when there are pastures that have bare soil between clumps of grass, that gives off a lot more nitrous oxide than when the grasses are, when it's sort of a healthy, full pasture. And there are also some kinds of forages that we can plant in those in pastures and grazing areas that reduce nitrous oxide emissions as well. They are sort of really good at scavenging the nitrogen. There's a tropical one that's great, but here we're sort of figuring out what they are. And in terms of manure management, my favorite thing is biodigesters, which really capture all of that methane and enable it to be used for energy. And in terms of applying manure to fields, you just want to put it down at the right amount so that you're not over fertilizing with it, because that gets off gassing just like synthetic fertilizer. And also at the right time, like not right before a rain, because it's going to wash away. But there's sort of a right amount of manure and a right time to apply it to fields. If you can smell it a lot from far away, it's probably too much. In terms of reducing synthetic fertilizers, well, there's doing synthetic fertilizer better, like not overusing it. And now they have slow release kinds and all kinds of, there's the 4 R's, right place, right time, etc., for doing a better job with synthetic fertilizers. There's using compost and manure instead, which can have their own issues in terms of emissions. There's using nitrogen fixing plants like legume cover crops as a source of nitrogen. They also give off some nitrous oxide, but it's less, and they don't need all the heavy manufacturing with a lot of fossil fuel being burned to make the synthetic fertilizers. And then there's integrating livestock, which can do some good and can do some harm depending on how it's done. And we're still really missing, despite how many regenerative farmers really love that and swear by it, we just don't have a lot of data on it yet. And I'm looking forward to there being more of that. And hopefully we can really back up some of the things that farmers are excited about there. With rice, we don't live in a place where people grow rice, but there's cool things you can do to reduce the methane from rice, mostly by going back and forth between wet and dry instead of having a paddy be full of water all year round or all through the growing season. There are some other things, the crop residues. This is like the stuff that's left over afterwards, the rotten pumpkins and pumpkin vines and corn stalks and all that. It looks like it's better when you don't till it in. If you leave it on the surface, you get less emissions than if you plow it under the soil. And the other big one here is peatland soil. So our world's peat lands, these are sort of very high organic matter wetlands. They store about 30% of soil carbon on about 3% of the world's land. So they're very, 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 very high in carbon. And Massachusetts actually farms a lot on peatland. That's our cranberry farming. And as cranberries are disappearing from Massachusetts, as the industry is disappearing from Massachusetts, there is an opportunity to restore cranberry bogs into healthy peatlands again, which will continue to sequester carbon for thousands of years. Whereas irregular farm type systems might give you a couple of decades of carbon sequestration. Wetlands are exempt from that. Because there's no oxygen under there, the stuff can't ever break down. So they just keep building up more and more and more and more and more and more carbon for thousands of years. And that's actually how, like, where coal comes from is old wetlands. So protecting and restoring wetlands is a really big deal. We wrote about that a bunch actually in this Healthy Soils Action Plan for the state that I was part of the team working on. And the state is at work on cranberry restoration right now. It's an active thing. It costs about $22,000 an acre. So it's very expensive to do, but it has it will have an impact for thousands of years. So it's tricky to figure out how do you allocate that versus other things you can do in the budget and so on, but it is super important. That was emissions reduction. Now we'll move on to sequestering carbon. This group already knows all this stuff already, but I'll just, as a reminder, this is, if you can think back to learning photosynthesis in high school, many of you will have learned about photosynthesis in school. This is the process where plants can, and some other things like algae and stuff, can remove carbon dioxide, excess carbon dioxide from the atmosphere, which is what we want to do, is remove that excess carbon dioxide. And they break off the oxygen, release the oxygen back into the atmosphere, and then they make that carbon into all kinds of cool things, into sugar and into starch and into fibers and into lignin and woody tissues and all of that. Some of it's given off through the roots to feed as sugars to feed soil organisms. Some of it stays in the roots and the tissues of the plant. In the case of an annual plant, it's going to die and decompose within 1 year, and some of that carbon will end up in soil organic matter, and some of it will return to the atmosphere. In the case of those sugars that are given off by the roots, again, some of that will become long-term organic matter in the soil, and a lot of that will decompose and head back out. And in terms of the perennial plants, like trees, like an apple tree, let's say, every year, some of the root hairs, a bunch of the root hairs will die, and a bunch of the leaves, all the leaves will fall off. Some of that will head back. But for the life of the woody tissue of the main roots and the tree, that carbon is held. And if you make, let's say, a piece of furniture out of that apple, or a house out of a tree, for the life of that wood, that carbon is sequestered. But eventually, that furniture will rot away, or the house will rot away, and the carbon will return again to the atmosphere. So some of it is sequestered for a long time, hundreds of years, if you do it right and hold it in there well and maintain the good practices, and there's no major climate disaster or human disturbance. But it's relatively short-lived compared to some of these other processes that sequester carbon for millions of years. But I'm not really worried about millions of years. A couple of decades, a couple of centuries would be great. We could use that right now. So, and the rates of carbon sequestration, the how many tons of carbon per acre or what have you, really change between different practices. Some are much higher than others. There's a lot of, and within a practice, there's a lot of variation too. Something might do really well on one farm and really poorly on another farm. So wild variation, lots of variation. This is part of what makes it hard to predict, is the same practice may give you really different results in different places. And it also varies by climate. So the same practice in a dry place will give you less usually than in a humid place. So there's just a lot of variation. The tropics versus cold climates is different. The amount of moisture you get is different. It's different in different kinds of soils. And we actually have, I learned this year, there are about 300,000 soil types in the world. And there are only about 370,000 species of plants in the world. So there are almost as many soil types as there are species of plants on the planet. And every one of them is a little different when it comes to carbon sequestration. So that's part of why the science is taking a long time, is it's a wonderful, amazing, diverse planet that is very complex. That was a fun thing to learn this year. And as I mentioned before, generally we're looking at 20 to 50 years in terms of how long you'll get carbon sequestration, until basically the amount that's brought down is balanced out by the amount that's given off. And really, it's mostly in soils and ecosystems that have been degraded that there's a chance to come back up to what it once was. Usually we consider the ceiling is, well, if any farm in Massachusetts used to be a forest, probably, or a wetland. So if we can get it back up to the level it had before it was deforested, that would be amazing. Really, if we can get it back to 2/3 of what it was, in most places we're doing well. There are a few places where you can do better than it was. If there was a limit like rainfall or a lack of phosphorus or something else, it's possible to go better than it was before. But for most of us, we would be doing great if we could bring farmland back to where it was before. All different kinds of ways to do this. There's a huge toolkit of practices in terms of growing the annual crops that we know and love. One set is conservation agriculture, where you're reducing tillage, so you're not plowing so much, where you're using cover crops. and where you're rotating crops from year to year. Most of the conservation agriculture as we know it has a pretty heavy reliance on herbicide and GMOs, which a lot of people aren't wild about, including myself. But there are also organic forms of conservation agriculture. And in fact, a lot of people here in the Pioneer Valley are doing that. Organic no-till is a kind of conservation agriculture in that sense of things. So organic has the advantage of not using herbicide and stuff, but it has a higher reliance on tillage for weed control. So those are kind of these two, the better conventional producers are figuring out this conservation agriculture stuff. The better organic producers are starting to figure out how to do organic no-till and reduce till. And they're actually learning a lot from each other and kind of growing into this new thing we call regenerative agriculture that's trying to pick the best of both worlds. That's sort of a roundabout way of saying that. But organic, even with a lot of tillage, has a pretty good rate of carbon sequestration. Because there's so much cover cropping, there's often compost application. It can make up for that weakness of tilling a lot, which burns up the carbon in the soil. And there are some really great examples of people doing it. This is sort of one of the hot spots in the country of people doing this right now. So that's very exciting. But really to do it at a big scale with tractors is the missing piece there. That's what people are trying to figure out. And there's some kind of cool new techniques to do that, but fundamentally, we're not really there yet. We're not really seeing lots of large organic farms going no-till yet. That's one of the things that I'm watching closely. A lot of people are trying to watch closely. Then we have different ways of bringing in trees around the edge of the farm, like windbreaks and riparian buffers, where you're planting trees along streams and rivers to prevent, to help water quality, but also sequester carbon. And there are some ways to get the trees into the middle of the farm, and that's where the carbon really starts to kick in hard. You see higher carbon sequestration rates. We don't have great examples of this here yet. There are some farms who are doing like rows of apples and berries and stuff in between, which is great. The thing that for this climate, the kind of tree intercropping agroforestry that's been worked out really well is winter grains like wheat and rye and barley that you plant in the fall. They grow over the winter and you harvest them in the spring. Those are really compatible with deciduous trees because the trees drop their leaves, the plants get to grow over the winter and into the spring before the trees have leafed out. So they're sort of in the same place, but they're not using it at the same time. Unfortunately, this isn't a place where people grow a lot of those grains. We're growing mostly vegetables in the summer and corn in the summer, right? So that's a little bit more tricky. That's still, we could talk about that if people want to talk about ideas there, but there is lots of agroforestry in cold climates, but not so much for the kinds of crops that we grow yet. Then there's perennial crops, whether they're an herbaceous perennial like asparagus or a woody perennial. The more woody, the better in terms of carbon. And we do have lots of great trees that grow here that do all kinds of fruits and nuts and stuff. And we have some trees with edible leaves. I actually just published a paper analyzing the nutrition of the world's vegetables in terms of our ability to address the nutrient deficiencies that are hurting people so much around the world, including very much people in the United States who are suffering from heart disease and diabetes and osteoporosis and a number of challenges which are related to us not eating enough vegetables, really. And the vegetables which were highest in the nutrients that we so desperately need, the group with the highest amount of those nutrients is trees with edible leaves. So edible leaf mulberry and fragrant spring tree and edible leaf goji are some of the world's most nutritious crops. And I grow a number of these trees with edible leaves here in my backyard. I quite like them. They're easier to grow than spinach, but they don't taste as good as spinach, right? Nothing tastes quite as good as spinach to me, but they're easy to grow. Then we have some grazing systems, better ways to do grazing. And the first like basic level is just to get the right number of animals in there so that you're not over grazing. So getting your stocking rates right, you know. And then there are these fancier systems like adaptive multi-paddock grazing that a lot of people here do in Massachusetts. Is very common practice, where you're very intensively watching and moving those animals, sometimes on a daily basis, to move them right where you want them. Um, they're still making methane. They're making a little bit less than they would. Because the forage is of better quality and they're maybe healthier. Um, uh, but there's a few studies that show very high carbon sequestration rates for this, high enough that it becomes carbon negative, that the sequestration outweighs the emissions from those animals. The question is what happens in 30 years when that soil becomes full of carbon again? They go back to being net emitters of methane and nitrous oxide, right? Um, so it's not a perfect solution, but it is very elegant and lovely and does a lot of things really well in terms of ecosystem services and soil building and health and humane treatment for the animals and all that. Those are good things. Um, and there have been some wildly outrageous claims for the carbon potential, the climate mitigation potential of this practice, which don't stand up in terms of science at all. Including very recently, there have been some claims like that by the Rodale Institute, who I love, but oof, that was bad. Um, um, yeah, okay, that was grazing. Then we have silvopasture, where you integrate trees into the pasture. And this is where you get really, really high rates of carbon sequestration. Um, um, as with tree intercropping, you have to get the right species of trees and the right spacing between those trees. Otherwise, they make too much shade for the things underneath them, for the crops or pastures underneath them. But if you get it right, it can increase the productivity of a pasture quite a bit. The trees can make food for the livestock as well, including these leaves that are high in tannins that reduce their emissions. And the other nice thing about silvopasture, and we do live in a part of the world where that's a very appropriate practice, is if you're growing timber trees, you can harvest those trees for timber at the end of whatever it is, 30 years or something, make a house out of it. So that carbon is going to be held in there for 100 years or more, let's say. And then you can plant a new tree and restart the clock on carbon saturation so that you're still sequestering carbon. Even if the soil is full, you're growing new carbon in the tree, and that way you can always have some livestock there, but they're never a net source of emissions. Now, would it be better in terms of carbon to not have those cows there at all, or goats or whatever there? Maybe, yeah. We can argue about that. um, but it is a much better model. And I'll just say one of the things I'm really excited about that would work fine with pastures around here is you can harvest grasses and clovers, among other things, basically run them through a giant juicer. Um, and then it's just like at that point, the grass juice or the clover juice is like milk or soy milk. If you want to make cheese or tofu, you simmer it, the protein coagulates out, you can skim it off, and you get a product called leaf protein concentrate, which is sort of like cheese that tastes like wheatgrass juice, which is gross. But you mix it in with other things. It's about 50% protein, so it has more protein than beef, and it makes more protein per acre than anything, more protein per acre than soybeans, more than beans, way, 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 way more than cows or sheep ever can. Um, so in terms of using the minimum amount of space to feed humanity the protein that we need, leaf protein concentrate is absolutely the best thing we can do. It's also the worst tasting of all the kinds of protein we might enjoy. But again, if you mix it with things, I mix it with guacamole when I make it at home, it tastes great. You mix it into things you're baking, it tastes perfectly fine. Um, so it's not as though the only thing we could do in these systems is have livestock. We also could have trees and then make leaf protein concentrate with the grasses that grow in between. Um, but I I think animals are cute. I like having them as long as they're done well. There's some other kinds of systems for livestock as well. This one on the right here is a local business. This is Walden Hill Pork, where they collect acorns on a large scale with like golf ball picking up machines and stuff. They distribute the acorns to different pork producers, and then they buy the pork from those and sell them under their own brand. So I think they have about 8 different growers raising them. So here's an example of raising pigs that doesn't compete with human food production at all. They're not eating corn or soybeans or whatever, right? They're eating acorns. So that starts to look like a different carbon footprint and amount of land taken up by those pigs and so on in order to do that. So and a really interesting local business is very delicious. One of the really fun things, we're almost done here. One of the really fun things I've enjoyed in writing this drawdown publication is learning how many of these practices that we do just for emissions reduction or just for carbon sequestration actually have big impacts across the board. So conservation agriculture we do because it sequesters carbon, but no-till also increases the sink in soil that soaks up extra methane, which is a pretty small sink, but it does bring down a little methane. And it reduces nitrous oxide emissions from crop residues. And plowing is the most energy intensive thing we do on farms. So it reduces the energy from tractor operation, and it can increase yields, meaning it's taking a little bit of pressure off of deforestation. Tree intercropping has benefits that the trees that fix nitrogen can release us from having to use some synthetic fertilizer. Biochar, and I'm not one of these people who's wild and crazy about biochar in every way, but when you feed it to ruminants, it looks like it can reduce their methane emissions. It's one of the things you can feed that reduces methane emissions. It also, those same animals who eat it, it reduces nitrous oxide from their manure. And when you apply biochar on fields, it can reduce nitrous oxide from crop residues. And it can increase yields in certain places in the tropics and in sandy soils here. And it itself represents a form of sequestered carbon. Managed grazing, I think we mostly talked about all those things. And in silvopasture, I think we talked about those mostly too. So some places you can go to learn more. This publication will be out from Drawdown, and really within the next month, by the end of the year, it should be out. And you can go to my website too, if you like, the Carbon Farming Solution there. That book is now a little out of date, but it's still very helpful. It has a lot of good stuff. And the new publication from Drawdown is called Farming Our Way Out of the Climate Crisis. So that's our little walk through agricultural climate change mitigation, a very broad walk through. And I'd be happy to take any questions at any time. So thanks, everybody.
Hi, everyone. I'm Carol Horowitz. Thank you so much, Eric. That was a really great talk. And I'm from the Farming, Forest, and Food Systems Committee of CAN. Okay, here's the first question, Eric. Should we focus our efforts on growing most of our food locally?
I would say yes and no. Some things it makes a lot of sense to grow locally. I mean, the main reason to try and grow stuff locally is often thought of as transport. Transport emissions aren't that big a part of the food system compared to other things. Depending on the food product. So like the berries that are flown in from Chile in the winter have a very high carbon footprint. But some other stuff isn't really all that bad. And sometimes actually local agriculture is worse because there's so much more driving of individual cars around to individual farms and stuff. I think of the food hub as the way to make local food have the very best sort of superior carbon footprint in terms of transportation. If you're making people drive more than they would have, that's worse. the nice thing about doing food locally is that you can tell how it's being produced and you can tell if it's being done in climate friendly ways. So I think a combination of food hubs, um, locally grown food that is accessible without having to drive any extra. And I mean, I grow a lot of my own food in my own backyard, including I have like tangerines and stuff in my greenhouse right now with no heat, no electricity, nothing, just a fully passive, very insulated greenhouse. So there's an awful lot more we can do locally in the very best way possible in terms of climate. And I think we should do that. And also there are things that aren't necessarily that bad to bring in from other places in terms of the carbon footprint. But that's the only thing that matters. There are also other very good arguments for local agriculture. Um, uh, um, that's a little bit rambly, but that's my 2 cents on that. We could do more on that if people would like. We could cover more on that.
What would be the best specific foods or food groups and methods of agriculture to grow and incorporate for New England, New York area that would help reduce climate emissions and sequester effective amounts of carbon?
Sure. I mean, leaf protein concentrate is absolutely the best thing we could be doing. As I mentioned, it's not necessarily delicious, but it's very, in terms of protein production, I think it's really the best possible thing. Any of the tree fruits and tree nuts are really, really good in terms of carbon sequestration. Very, very good. Very, very productive. Excellent, excellent carbon. You know, if you want livestock, then livestock raised in silvopasture or like hogs that are eating acorns is pretty darn good. Or chickens that are eating food waste is pretty good. And, you know, there are people here producing any kind of vegetable, but if it's grown in one of these organic no-till systems, that really represents to me the highest and best way we have right now to grow vegetables here. So it's maybe not, doesn't matter so much if it's an eggplant versus a tomato, as more like, is there mulch? Is there cover cropping? Is there compost being applied? Is there minimum amount of tillage, if any, and so on? That's the way I would think about that. Yeah, but a lot more nuts and fruits. A lot of these things are very good for us, very healthy too. So
Do you think we'll be able to get people to eat more of that leaf concentrate? Is anyone working on that in this area?
mostly people are working on it for livestock feed rather than human food as like a replacement for soybeans, which is a really important thing to do, is to replace less soybeans. Less deforestation in the Amazon is really good, because pigs and chickens are a lot less picky than people are about what we eat. There's a chef in Montreal who's doing some work with it, but I don't know anybody here in the valley besides me with my juicer in my kitchen doing it at all. And it's kind of a pain to do at the home scale. It's really something that needs a more, a larger scale operation to do it efficiently. And I think the perfect product for it would be a hummus, like a bright green hummus that would have 20% leaf protein concentrate or something in it. I think that could be a very marketable, super high protein, could be very tasty, vegan protein product that I think could be outstanding. I've been trying to get, if anybody wants to start one, send me an email. I'd love to talk to you about how you might do it and where you might start.
Could it be a powder?
Absolutely. Yeah, you can totally dry to powder it. Yep. People put it in tortillas, they make it into bread, they make it into noodles, in the food processing world, it can go into anything really easily. It just turns a bright green, because it has all these vitamins in it and stuff too. Basically takes a leaf and gets rid of all the water and all the fiber. So you're left with all the vitamins and minerals and protein, which is really cool. Yeah, you can make it from alfalfa. That's pretty easy to grow here. Most grasses will work really well, clovers, all kinds of other things, poplar leaves, all manner of things. So I think that's something that's very exciting, but it's way farther out than most of us are thinking. But that could be the protein in, let's say, if you still want to have eggs, that could be the protein that you feed to chickens so that you can have eggs. And then you're at least not, I think it's the lowest impact protein production we might be able to have. and it sequesters carbon as well if you do it with a perennial grass or legume.
Are there already good silvopasture livestock sources to support and promote in our region instead of promoting some of the pasture-based systems that create more emissions and sequester much less carbon?
There is a great book called Silvopasture, which is a really great read by Steve Gabriel. He's in Ithaca, New York, so not too far away. And there is a growing network of people around here starting to do some silvopasture. I can't name any names right now; none are coming to me, but I know there are some people starting to do it. And I do think that this AMP grazing can be really great on its own, but it's better with trees. So why not put some trees in? It's better with trees in terms of carbon, and if you get the right kind of trees, then it's better. It can be really great for the animals as well. Yeah, but I don't have a particular like supplier that I can send people to buy or anything just yet. We're still early stages on that.
Okay. Going to a more political question, are there people on President Biden's team who are paying attention to farming readjustment as a way to make reparations and help help fight the climate crisis?
The short answer is yes. I haven't. I went looking for the full plan the other day, and I don't think they've released their full plan yet. I'm not entirely up to speed, but it is something he talked about a lot in his campaign talks about agriculture. So I do think we'll be seeing some things there. Yes, and the Green New Deal folks have given it a lot of thought as well. So I think there's a lot of people who've spent the last 4 years writing up what they would like to see in terms of U.S. policy. And now they're all going to argue for what they would like to see happen. So hopefully we'll see some real improvements. It's hard to do worse than we're doing now.
So back to the livestock question. Some of the people the proponents of grazing livestock to sequester carbon, they say that researchers who don't find this to be true are using an outdated way of looking at carbon cycling. Are the scientists and researchers generally using consistent and effective methods to compare carbon sequestration in all types of agricultural systems, or is there some confusion or inconsistencies in counting it?
Well, there's definitely confusions and inconsistencies, yes, across the board. Yeah, I mean, you hear that from the grazing folks, and I've read some of those papers, and I mostly agree with their critiques. With that said, we only have like 3 or 4 studies that I've seen that really show high numbers for these fancy kinds of grazing, like holistic grazing. And I don't think that 3 or 4 studies is enough to declare that the revolution is here for the whole planet. That's way not enough data. And there are also studies that have shown really low numbers, even if their methodology isn't perfect. So I just think it's a little early to make wild claims there, even though it would be extremely good news for everybody if they were true. And we do have a couple of, this is really different from like 3 or 4 years ago. We have a couple of really good killer papers that come out on that. But I personally just don't see it being, ready for prime time in the same way that some of these other practices are in terms of the science, in terms of how to do it, and a large number of people doing it and consumers wanting it. It's doing great. So as far as like adoption and interest and enthusiasm goes, it's doing awesome. But you got to have, the carbon numbers have to be there, and I just don't quite see them there yet in the way that I want to see them. I do think we will be getting answers to that over the next couple of years. There's even a new model that just came out. This, I think, is Mark Ritchie is the name of the scientists working on that may be able to resolve some of these issues. But fundamentally, it's still not a solved question as far as I'm concerned in terms of the science, as much as I want it to be true.
Okay, most of the carbon agriculture solutions are about large-scale farming and ranching practices. Do you think small-scale farms, personal landscape, and local public land can make a meaningful contribution to the solution if there's a push to encourage lots of people to participate, like, for example, your home permaculture garden?
Yeah, I totally think that. Actually, in Massachusetts, We have about 4% of our land is in agriculture and 9% is in lawns and landscapes. So we have twice as much land there as we do in agriculture. So absolutely, I think that, yes, very much so, yes. And often smaller farms can be more intensive and can grow more food on a smaller amount of land, which again, can take some pressure off in terms of deforestation and stuff in other places. So yeah, I do think that.
How does soil become saturated or full of carbon?
Okay, well, the short version is that there are different kinds of pools of carbon in the soil. Some of them are really short-lived, like it's going to be gone in a couple days. Some of them cycle maybe more over like a year, and then there are these longer-term pools of carbon. The carbon that's held in the soil in the long term is stuck to clay particles and mineral particles in the soil. It bonds with them in such a way that nothing else can break it off. And I got to talk to one of the world's great soil scientists about this, and he said, it's like when you're cooking something in a pan and you burn it and it just gets really, really stuck on the pan. That's carbon that's bonded to a mineral. You can't get it off, no matter how much you scrape. That's basically what happens, is these carbon particles get bonded to mineral particles. These carbon compounds get bonded to mineral particles and they just won't go away, so they can last a long time. However, if you plow the soil, they disperse. If the soil dries out really badly, like if your land turns into a desert, that can do it. So there are ways to lose that carbon, but basically once it's found like that for a long time, it's there. But there's only so many mineral particles in the soil. So once every mineral particle is bonded to a carbon compound, or as many as it'll fit or whatever, that's kind of it. So you can add more carbon after that, but it's going to be in these shorter lived pools. It's going to be much, much more vulnerable to disappearing quickly. That's my understanding. There are some exceptions in certain kinds of soils. The wetlands are a big exception, as I mentioned, and there's some other, people are working on a lot of ways to sort of hack the issue of saturation, which I think is really important. And not everybody agrees with that, but I haven't seen convincing evidence that that's not the case.
Someone wants you to mention your Edible Forest Gardens book, because it might interest people.
I have a book called Edible Forest Gardens that I wrote with a guy named Dave Jackie, and it's about a gardening practice that's a very, very, very high carbon. It has a lot of trees, it has other perennials, it's a no-till system and so on. It produces fertility through nitrogen fixation instead of synthetic fertilizers. So at the time we didn't know that, but it turns out that it's really an ideal system in terms of carbon.
What are the costs of making biochar in terms of energy and emissions? I think it's pretty controversial.
There's a lot of different ways to do it, and there's a lot of things you can make it out of, and you can sort of optimize it for energy production or optimize it for biochar production, but maybe not both. You sort of have to choose a little bit of which way to go. I see biochar as having a very modest role within agricultural and land-based climate mitigation, limited mostly by how much of it there's actually a good use for non-carbon reasons. And the main limitation being how much biomass is available for it. At Drawdown, we had much lower estimates for what its potential is than a lot of other people, because we actually looked at how much biomass there is in the whole world and how much is being used for other things, including crop residues and everything else. And we just didn't find that much left over for it. I just wrote an article about this issue of biomass availability in a recent, I think the July issue of Scientific American, that a lot of different climate solutions all want biomass. They want it for burning. They want it to make insulation. They want it to make second generation biofuels. They want it to make biochar. They want it to make bioplastics. And there's only so much of it to go around. Meanwhile, we need to protect forests and we need to restore forests. So we sort of said, let alone bioenergy carbon capture and sequestration, which is becoming sort of the elephant in the room there. So we sort of said, well, okay, if we're protecting forests and restoring forests and blah, 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 how much might there be? And the answer was a lot less than everybody would like. Some, but a lot less than everybody would like. It's shorter than I wanted. They cut out a lot of the good stuff, but there's a lot of good material in there. Unfortunately, they don't make it viewable. You have to like buy the issue or, go to the library and read it or something. You can't get it on their website unless you have a subscription. So, but it was a good walkthrough with Dennis Garrity, who is like the world UN dryland ambassador, and he's runs the Global Evergreening Alliance and used to work for the World Agroforestry Center. So he has a really good perspective on global biomass use as well. We sort of looked at what a best case scenario might look like, I guess, for biomass use. Yeah.
Thank you. Are you concerned about giving acorns to pigs when it's an important source of food for wildlife?
Well, in this case, mostly they're I think they're like grabbing them out of parks and stuff. So it's competing with some squirrels, but in a good year, there's an awful lot of acorns. In a good year, there's more acorns than they can all eat. But ideally, I would want to see us growing things to feed to those pigs ourselves, like growing chestnuts, which yield way better than acorns anyway, and feeding those to pigs. But really, I'd like to eat them myself. I had some for dinner tonight, right? So,
acorns or chestnuts?
Oh, chestnuts. Yeah, I'm concerned that if we harvested huge amounts of acorns from the wild, that would definitely be competing with wildlife. Yes. I think this business maybe does like 20 pigs a year, so I don't think they're quite cutting into the squirrel and deer market yet in that area.
And that leads to another question, which is what kind of nut trees are good to grow here? You mentioned chestnuts.
Chestnuts are great. It used to be that 1 out of every 4 trees here was a chestnut when before the American chestnut was devastated by this disease. So yeah, I think chestnuts are a really good choice. They're delicious. Hazelnuts are great, and they're sort of much smaller. They fit in a smaller yard. And in terms of the bigger trees, actually the heartnut, I think, is the very best walnut that we can grow. It's a good, like a grafted, nice heartnut. They're really shaped like a heart, and you can crack it open really well. And there's a nut inside that looks just like a heart and tastes really good. It's amazing. So if I ever get some more land, I'll put some heartnuts in on it. I'm very enthusiastic about them.
Are they large trees?
They're big trees, and they store well. Whereas chestnuts, you kind of have to eat them within a couple months or they're done, right? They don't last as long. So they're delicious, 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 delicious. But they're a little, they don't store as well as some of the other nuts do.
Where would the seaweed used as an additive to livestock feed come from? Is there enough supply? I know that harvesting of seaweed for human consumption is way up and is a problem already in some areas, Maine included.
Well, this particular one that people are excited about, Asparagopsis, are starting to grow commercially in Hawaii. So I do think we're going to see more of that coming into the market. There's, like anything, there's good and bad ways to produce seaweed and good and bad ways to wild harvest seaweed. There's a lot more room to grow more seaweed. The ocean is really big. And right now only a tiny amount of the ocean has seaweed being farmed in it. And seaweed actually is an amazing carbon sequestration tool as well, but it has to be done, properly and stuff. There's good and bad ways. And actually Drawdown is working on a whole set of ocean solutions, and we'll have sometime in this next year marine protected areas and seaweed production and fisheries management and a bunch of stuff like that. And I'll know a lot more about that when they're done. I live on land and I work on land, so that's more where my knowledge is. But we don't want to see, in the name of mitigation, more environmental destruction or human atrocities. And if anybody could drive that, it would be the livestock industry, right? Surely they could do something horrible with it. I'm more worried about some of the other livestock feed additives than about seaweed, actually.
Unfortunately, I think that's it. But I learned a lot, and I bet everybody else did. And I hope that we can have you back sometime, because seems like there's a lot of other subjects that you could talk about. So that would be wonderful. Thank you so much.